All right, so I can't use this then until after. So this controls this. Okay, cool. So enough of that boring history crap that Kurt was talking about. We're gonna go over actual what SSH is and how asymmetric cryptography is kind of used under the hood with SSH. So does anybody know anything about SSH in here? First of all, really? Yeah. You know some stuff about it?
Sure.
You know, right? Nick, you know a lot about cryptography, right? So SSH stands for Secure Shell, and to understand what Secure Shell means, you actually have to know what a shell is. And so a shell is essentially, I like to think of a shell, I mean, I'm sure this is far from the actual formal definition, but like the operating system has a bunch of sensitive features, and you're going to look it up on Wikipedia now. So the operating system has a bunch of sensitive features, like this big sensitive turtle. And the way we can interface with all these little sensitive features is through its shell, right? It's got little holes that we can poke and do stuff. It's so cool. I know, it's good.
You just compared an operating system to a turtle.
A cute turtle with a nice shell. Yeah, so it's a sensitive little turtle, and we can poke through its shell and make it do certain things. So the shell is how we actually interface with the operating system. A shell can be a graphical shell, it can be a command line shell. So this is an example of a command line shell. I can run operating system tasks within this and mess with services in the operating system and things like that. So that's what a shell is. So the point of secure shell is to kind of give us access to a remote shell on another computer. Because this is really important if I want to run some cool tasks on a computer that I'm not in front of right now, but I can access over the network. I can use secure shell to kind of shell into that computer so I can essentially act like I'm sitting right in front of it. So how is it useful? Yeah, so it's a network protocol. Like most network protocols, they're sort of married to some specific port. So secure shell data is transmitted over port 22, and that's where the connection happens. This is kind of irrelevant, but might play into something that we're going to see later. But a lot of protocols have different ports and things like that. So Secure Shell runs over port 22, FTP runs over port 21, and all main web traffic goes over port 80. So I want to just demonstrate what that even means. You can mess with ports a little bit in the browser here. So if I want to go to like google.com, what I'm really doing is google.com. I'm really accessing port 80. And so this is going to let me touch a port on the Google origin. And so when I just do 80, it's just going to redirect me because the browser says, oh yeah, I would have normally served it up on 80 anyways. Here you go. Here's what I would have given you. Messing with ports in the browser and stuff like that is really useful when you're doing local development. So mine, I use 4200 a lot for certain projects. I think that's what the Angular CLI uses by default, actually. It serves a web browser up on 4200. If I wanted to serve another web browser up on localhost, I could, or another web app up on localhost, I could use 3000, things like that. So that's just essentially what the port is going to give us. So yeah, like I said, it's most commonly used to securely log in to a remote shell, often on Unix computers. And it again allows me to remotely manage operating systems, services, and resources, etc. So it requires an SSH client and SSH server. So SSH is a protocol that's going to allow me, the client, to connect to a server that is listening on SSH. And to make sure that the connection is secure, which is where the secure part comes in, secure shell, you can, I think by default it asks for passwords of the remote user, but you can optionally generate a SSH, an SSH key pair for the client to kind of interact with the server so that it kind of has a more verified identity of the client as opposed to just using passwords. You can crack passwords really simple, but you can't really spoof what an SSH key pair can give you. So this is really, really simple. I'm not going to go into the specifics of how to, how the math works behind SSH and RSA and everything like that, mainly because I don't really know much about it. But the really basic commands to generating an SSH key pair is you're going to use the SSH key gen command here. So you can actually, so down here on the slides here it says if you need help you can type man SSH key gen. Man is just going to be the manual pages. It's just referred to as the man pages. So if I type man SSH key gen, it gives me all kinds of information about it. What does the -p do? What does the -y do? All this kinds of stuff. There's a lot of documentation that it provides. And so if I do SSH key gen, I'm actually not going to generate a pair for you. But anyways, I need to specify a type of, I don't know if this is an algorithm to generate the key pair with, but in this case, we're going to be using RSA. to generate the SSH key pair. And that's going to generate a public and a private key, which is why it's asymmetric encryption. And so the biggest takeaway from what this command is going to output two files, and you never want to share the private key. And I'm actually going to generate one now just to show you what that kind of looks like. Keygen -t RSA. So it's going to say generating a public private RSA key pair. Enter a file. So by default, it's going to say, so this is going to act as an identity for your computer. And so by default, it's going to try to save it as ID_RSA. Well, I've already generated a pair for this computer that acts as this computer's identity. So I can say something like demo key, and I don't want a passphrase for it. A passphrase would basically protect the private key. So if some application tries to use the private key to generate a public key based off of it, it's going to ask me for the passphrase so that it knows that I'm the root that generated that key. I don't really need one in this case. So it's going to generate some random art image. And what I'm going to have in my, let's see. Okay, that's not good. Let's see what's in my folder. Oh wow, where did that generate it? Shit, did that just... Yeah, I think I just did.
I think it automatically overwrites these. I was surprised. I was sitting there like, wow, you really did this.
Oh, thanks for the heads up. Well, that just fucked me big time. So, cool. Anyways, so there's a really good chance that I just screwed myself. I want to check out with the public key real fast just to see. Oh crap!
Stack Overflow should come. You should look things up.
Are these different? They're totally different.
You could just overwrite it again.
C.
No, look at the end. The end is the important part.
All right, are these the same? PX4, 5.
Yeah. The end is what's going to be different.
Case. Yeah. Case slash. Oh my God, it's the same.
The bottom one's the same.
That's what mattered. Okay, so it didn't. Okay, that's cool. Anyways, I have no idea where it generated them. But let's assume that it generated IDRSA and IDRSA.pub. Holy shit. So that would have been awesome. So, anyways, optionally, the SSH keygen command here can take in a -c, which stands. What?
I didn't know what was going on.
Oh. That's fine. So anyways, optionally, the SSH keygen command here can take a -c argument. This is just going to stand for a comment to put at the end of the key. It doesn't really need to be anything specific. I usually use user at host, which is always Dom Ferlino at Dom Ferlino in my case. And so that's going to put that's going to show up at the bottom of the keys right here, which is where you see I have my public keys on my website. And we'll explain why that's not unsafe in the slides. So anyways, SSH keygen, it generated these keys for my computer to use. However, the computer doesn't really know about them. They're just regular files in a system. So if I want to actually use this as the real identity for my computer, I really want to know where that's saved.
What was the generate command?
I'm going to say, oh,
But it says user slash
Demo
Dom
key.
Ferlino.
It might be in the folder.
Oh, yeah.
that's what I was wondering. Oh, huh? Slash git?
CD desktop again.
Oh, okay, cool. So it's actually, it's in here. Shit, that was good. So, all right. So, yeah, back to the slides. So if I want to tell the computer about the keys that I just generated and say, hey, I generated these keys. Let's use them as an identity for this computer whenever SSH is required. I can spin up the SSH agent, which is usually kind of sleeping. I think this is -s for start. I'm not sure. You can man page it though. And we want to actually add the key that we just generated, which is normally generated here. So we say SSH add, and we add the private key. Again, you never want to show anybody or distribute the private key. Only the public key is what you want to give other people so that you can actually share information. So is that about it? Yeah. So once that's added, it's going to be added to the list of identities for my computer. Now we can actually talk about what it means to SSH into another computer and how we can do that. So There's a couple things that need focus, that need to be clear when talking about how to SSH into a computer. So there's really 4 main files that you need to focus on, and the top 2 on each of these are usually not too important for you to look at if you're SSHing into something like GitHub or things like that. But there's the SSH config file right here, and then there's the SSHD config. So on the client side, we have SSH config, and this is basically going to be the client settings. I don't even know what's in here. I don't think I've ever modified it, but it tells your SSH agent how to work with servers that it's trying to connect to via SSH protocol. On the server, the counterpart is SSHD config. Now there's an extra D here. This stands for, I believe, daemon. So it's going to be some background task that's actually going to be a little SSH server that sits on the server in this case. And it's going to be listening for connections on port 22 by default. And so it's going to be accepting client communication. That's what so this is going to be the configuration file for all of that. There's things like when to time out a client, after how long they've connected. To make it more secure, I think that by default it only accepts passwords, or at least accepts passwords through SSH. You can lock down your server and make it a little stronger by not accepting passwords and only accepting SSH keys if you want to make sure. What's that?
Does it have a default password?
No, it's the user. It's like the user at host, whatever the user of the server is that you're trying to get into. So I mean that can be cracked much easier than a key pair. So you don't really. So I mean, one of the first things I ever do if I set up some kind of server that I'm going to be SSHing into is always go into the D config here and disable allow passwords and enable SSH key and force that and stuff like that. So, but it's really you don't have to mess with this much at all. These are a little bit more important in case people don't know. In Unix operating systems, the tilde here is going to act as the home directory. And I just want to show what that means. So yesterday I thought that meant that would always mean, so this is root of my computer. I thought that would always go to the home folder. But it doesn't, because you'd have to look at the bash variable that has been set for home. And if I want to echo home, it's going to show me that my home directory is /user stomperlino. Same thing if I want to echo the tilde or whatever the tilde gives me. It's the exact same thing. So this is going to be representative of this little prefix of the path right here. So I can go into my .ssh folder in my home directory and check out a file called known hosts. And on the server, its somewhat counterpart is in the same place, .ssh after the home prefix, but it's called authorized keys. So the client known host file is just some file with no extension that maintains data of all the servers that you've connected via SSH with in the past. So in my cat is going to allow me to print these things out. SSH known hosts file. Okay, that's a mess. Let me show these in a text editor, probably be a little more clear. It's just going to be 3 lines of stuff here. So I've connected to bosley.club, which is a Raspberry Pi that's hosted on at my house right now. I've connected to github.com, and I think this is another GitHub server. I don't know, but it's just going to have the public keys relating to these servers that I've connected with on SSH. And the client uses this every time it tries to connect to a server. It uses this saved data to make sure that the server actually is who it says it is every single time. And yeah, so and then on the server, its counterpart is going to be the authorized key. This is authorized keys. This is probably a little bit more important. So basically, it's this file with no extension, and it's a list of public keys separated by new line characters. And basically, if I'm acting as the client and I want to SSH into some computer, how does the server know to let me in or not? Well, I can use a password and generate and type in the correct password for the user of the computer, but if that's disabled, I have to use a key. So what's really going to happen is we give the server a list of whitelisted keys, essentially, to let in. And then the server says, okay, this client's trying to connect to me. Hey, client, for all the private keys that you have, generate a public key that matches like its corresponding public key. And I'm going to check to see if that public key exists in my authorized key file. If it is, then you're a valid identity. I can let you in, and you're good. If not, then it just kicks you out, and no connection is made between the server and the client. So you actually have to have access to this file if you want to set up your SSH key to work on that server. And I'll show you exactly how that works in a little bit. I'm going to do a demo. Oh wait, this is the last slide, isn't it? No, it's not. Yeah. Okay, so that's the last slide. So Matthew. Why did you guess Michael? Is it? Yeah, it probably is. All right. So I'm going to show you quickly what SSHing does. We've talked about it. We talked about a little bit how it works, how the daemon files work, and the configuration, what a known hosts and authorized keys files is, and stuff like that. And but I want to show you how we do it. So SSH is a command, and we are going to SSH into some user at the host name, and that's pretty much it. I think you can specify a port if you want to go over something that's not the default 22. But in this case, we're not going to need to do that because the server I'm going to be SSHing into is going to be listening on port 22 for clients. So I have a Raspberry Pi set up in my house right now, and it's accessible outside of my intranet. And so the username of this Raspberry Pi is Pi. And so the host, I need some way to access my house. I can access it through my external IP address, but that's kind of annoying to type every time. So what I did was, and this is not a permanent solution, but I bought a domain, and so I bought a domain. It works though, I promise. And I bought a domain and I associated in the A record of the DNS settings my IP address with the domain. The domain is bosley.club, and it's actually running a little shitty web server right now, accessible, and HTTPS, which is really all that matters.
Do you have to pay for that HTTPS certificate?
No, I did not. I used something called Let's Encrypt, which allowed, it's like a automated certificate authority that can generate you free, automated, and open certificates. And it's awesome. So I use that.
Why is it free?
Why is it free?
You can charge like tons of money for those things.
Yeah, it's like 25 a year, 2 years or something.
I think it's more than that, but I don't know.
Absurd amount of funding.
Yeah, it's awesome. So it's amazing. Anyways, so I'm running this. This is the same thing as going to 7.6. I don't know what my IP address is, but whatever it is. If I went to HTTPS, actually you can't do HTTPS on IP addresses, but if I went to 7.6.236 or whatever my IP address is, they would bring me to this site because I have a web server listening on port 80. So anyways, if I want to SSH into that computer, I can do SSH and then type in the IP address here. Or I can actually say bosley.club, and the DNS is going to be responsible for translating this string of characters right here into an IP address. So I SSH in, my key works, and now I'm into pi@dompi, which is the local host name of the computer. So right now I'm actually controlling, I'm in the shell of this computer that's sitting in my house. And so I can, do all kinds of random crap and rummage through some files. And the web server that I'm hosting is in Bosley Club, and I have some Node.js stuff in there running and everything like that. But I want to show you guys what's going on the server when I do this. So if we went to the SSH folder, now again, all this is happening on the server. So it's like I'm sitting in front of it with a computer plugged into it. SSH slash the known host file, which I was talking about. No, not the known host file. The authorized keys, since this is a server. It's going to have 3 keys, which are, for some reason, it's not going to word wrap. But anyways, they all start with SSH RSA, SSH RSA. Okay, I guess there's 4 in here. And so these are the public keys that I allow access to on this server. Now you can't really do anything if you have these public keys. They're completely safe to distribute because before I connect to anything, the server is going to say, okay, I'm going to look at your private key, tell the private key to generate a public key, and if the public key that is generated matches any of the ones in here, then I can let you in. So you can't really spoof my identity by having my public key. You actually need my private key, which is kind of why I was worried I overwrote it, because I use that for a lot of things right now, and it would kind of give me a pain in the ass to deal with. So the comments here kind of help me tell what computers is what. Unfortunately, I almost always use Dom Ferlino at Dom Ferlino, so I never really know. It's like defeats the whole purpose of it. But anyways, this is the only useful one, and I have 2 Ubuntu machines, so I don't even know which one it is. Actually, I do, but I shouldn't.
Comment on the other one.
On which one?
Oh, no, yeah, you did.
Anyways, yeah, so authorized keys file is going to be a whitelist of public keys that are going to let me in here. So now my public key on my MacBook Pro is here. Somewhere in this authorized key file on the server exists this key. It's probably the last one actually. It is dvk/. But so I'm in the server. I can do all kinds of random stuff in here. But more importantly, I want to talk about a program called Screen, or as Kurt pronounces it, Tmux.
There's different programs.
I'm kidding. And so if I want to go on here and then, kind of do some awesome, really important tasks, right? Oh, okay, I need to do this command indefinitely. But now I need to leave, right? I need to actually make sure this is running on my computer, even after I shut this computer down or I close this terminal and all kinds of stuff like that. I can try to close this, but that's actually going to kill the SSH screen that's been up, which means it's going to kill the process on both the server and the client. Nothing's productive is going to happen. Or I can try to get out of this. Oh, Jesus. Okay. Yeah. So there's an alternative solution, and I think it comes installed by default on at least Mac, maybe not. I don't know. But called Screen, which is going to allow me to kind of tap into a virtual window that exists on. What? You don't think it does?
No, I know what it does. I like Tmux more.
Oh, I thought you meant. Yeah. Okay.
It exists to fall on Mac, or at least comes with iTurn.
Okay, cool. Yeah, I don't think I ever installed it on here, but I still have it. So on my desktop. But anyway, so if I want to, so I can actually tap into a virtual shell on this computer and run commands on it, and I can disconnect from that shell, and it's going to keep running on my computer. So that way, so right now, if I were to hit exit, I would actually be the connection to Club is closed, this and that. I'm back on my regular computer, my own shell. But if I want to SSH into there, and I want to run some task and then bail, that task, like I said, is going to terminate. It's going to stop. So I can use Screen to, I think just Screen will create a new screen, or it'll bring you to a window where you can choose to create a new screen, which is going to be a virtual, like a virtual shell that kind of opens up, and it's going to act as some sort of layer for you to interface with from the client. So I have a screen running right now, and that's how this web server is running. And so if I want to see the status of it, I can do -R, which is going to let me resume to, and it's going to allow me to pick which screen I want to resume to. I only have one open, so screen -R is going to take me to the only one that exists. Maybe, oh, that's annoying. But, well, let's see what happens. So if I, trying to see if there's a, yeah, okay, so I'm actually in the web server right now. So what I'm doing here is I can stop the web server in policy.club, sudo npm start. I'm going to run the node server, and every request, all the requests that I make to the site are going to end up showing up here. So this is going to be the HTTP code that corresponds with a response. 304 just means, I think, not modified, but which makes sense. I have a cached version of the site, and it's not modified. But every time I visit, I get to see this kind of traffic in my web server. Now, if I want to, if I was in that Python while loop like I was before, or in some other important task like this, and I wanted to detach, but keep this service running on the computer that I just SSH into, using Screen, I can do Control-AD, and I can detach from that screen. And that screen's still going to be running, and we can kind of prove it by showing that the web server is still up and running. But now I'm just in my regular access here, and if I want, I can hit exit, and that process is still going to be running on the computer, on the server that I was on. And so the shell that I was tapped into, that was not a screen shell, was killed along with my connection to the server. But the screen shell persisted because that screen application is running in the background on the server. So yeah, that's essentially why it can be useful if I have some server. I think DigitalOcean, you can SSH into like servers that they give you and things like that. So you can buy a little web server, spin it up, and SSH into it, and host an actual web server from it, and associate an IP with it, and all kinds of stuff, or a domain with it. But it's really useful to going into remote machines, and you'll often just hear me talk about web servers because I do a lot of web stuff. But that's what it's super useful for. I can SSH into all kinds of stuff. In this case, that Pi is running at my house. But if I have multiple computers that I want to SSH into the house, I automatically have my router in my house port forwarding 22 to the Pi, which means any connection that comes into my external IP address, which represents all the computers on my network, anything that comes in on port 22 gets shifted to the Pi. So if I want to SSH into my desktop, I have to just pick a different port and then set that up accordingly with my desktop and my router, and I can actually SSH into any number of machines as long as it's on an unrestricted port and it's set up properly on the computer and the router. So it allows you to pick a different port, SSH into multiple computers on the same IP address, stuff like that. But that's pretty much the basics of SSH. I think that's about all I got. Is there any questions? Yeah.
Do you use Screen for running your web apps?
What do you mean for running my web apps?
Like, do you use Screen for Bosley Cloud normally?
Yeah. I like, it's, yeah.
Okay.
Like, there's about a billion other different ways I could do it that are better. I just do it because it's super simple, and I usually end up taking the site down all the time and screwing with it and things like that.
What alternatives are there to Screen?
What?
Is there a Screen start?
Forever is forever, right? No.
Minded.
So Forever is nice. It'll just run a process indefinitely on the host machine. Tmux, as Kurt
I
will.
like PM2 for
PM2?
Yeah.
What's
You
that?
can just throw
It's managing node apps.
you can just throw an operation in the background on Linux by attaching an ampersand to it. What's wrong?
But that process will still get killed when you
Yeah.
you,
So if I do, oh, gedit's not on here. Shit. Was it text edit? I'm trying to think of.
You're right.
BI.
Yeah, but anyways, so there's, I know on Ubuntu I can, if I do like gedit and then like, yeah, so the ampersand is going to give me my terminal back, but if I kill that terminal, gedit gets killed, and I've screwed a lot of things up by doing that actually. But so yeah, that's kind of like that, but not quite. But I don't know, Screen's good, Forever is really good. Forever's, I would say in this case, much more preferred. Yeah, so that's kind of my workflow with SSH and what I do and managing the keys and stuff like that. And it can be useful. I want to talk about this a little bit. Why my keys are on my site. I like this because not only does it make me look super rad, but I can actually, so if I want to maybe make a new account on something that's going to require me to SSH or something like that, and I want all the computers I have to just have access to that, I can do it all in one go without having access to those computers to saying, okay, what's the public key, copy the public key, pasting it into the web client. I would have to do that on every machine, whereas in this case, as long as I expose my public keys, I can throw these public keys on some authorized keys file all at once from one of my computers, or really any of them, as long as you can access the internet. So technically, you guys could copy my key, set up an SSH server, and throw my key into the SSH, into the authorized keys files, and I'll probably never know about it until I try to connect and it lets me in for no good reason. But you could allow me, you can kind of give me access in here, but you can't really do much more past that because, again, it's a mathematical trapdoor function.
To send messages, right?
Yeah. You can use it to encrypt any kind of data. Which, I mean, these protocols just use these keys to encrypt data, but we could manually do it, of course, and stuff like that. But the reason it's safe to expose your public keys is because it's a trapdoor function. You can never go back. Well, never. I shouldn't say that, but it's pretty much can't go back to a private key from a public key. You can only go from a private to a public. Did I say that wrong the first time? I don't know.
It's not a fun.
Okay, cool. Anyways, yeah, so that's what I got. The site's pretty sweet.
Why haven't you changed your clear command to just clear :ls?
What do you mean? Oh, like in RC?
Type clear and just it does clear :ls.
Yeah, I don't know. I really don't know. I love doing that though.
You really always gotta click,
Yeah, normally if I'm thinking about something, I'll sit here and just do this. Actually,
I understand though. I usually type it separately, like I hit clear, enter ls.
see, I'm way too efficient for that, Juanita.
You don't waste time typing clear.
No, I don't like
Clear :ls everything.
So yeah, any other questions with SSH and stuff like that? Yeah.
Talk about SSH config on your end.
Yeah, I mean, I touched it. I've never.
Before we go too far into that, does anyone have any questions about encryption in general?
I'm gonna kill this recording too, by the way.
Anything else?
See you guys.